السلام عليكم. دكتور نضال الصالحي, Faculty of Business, Petra University. Um, uh, Hi class. If you still remember last meeting, we stopped here. We were discussing the quantitative methods, and as you know, there are two methods or models for quantitative methods, which is time series and causal forecasting. Of course, we started last meeting with the time series method, and as I told you last meeting also, that there are four methods for time series under the time series model. We will start with the first model, okay, or first method, which is the naive approach. Now, the naive approach, they call it naive because it will only assume the demand, for example, for sales next period, the same as the most recent period. For example, if you want to forecast your sales for the month of, let's say, February, then it will be the same as January. Okay, as we can see here, 68 our sales was 68, for example, in the month of January. If you want to forecast your sales for February, then it will be also 68. That's why they call it a naive approach. But of course, you have to know that this approach is cost effective and it will not take time. It's easy to do. It will be only a good starting point for other methods, as we will see later on. Now, the second method, which is also easy to apply, which is the moving averages method. If I want to, for example, to forecast my demand for next month, then I will depend on the historical data of previous month. Okay, that's why we say that moving averages is a series of arithmetic means. Okay, moving averages is equal to the sum. By the way, this sign is sum. Okay, it means the sum. If you print it out, it will be it's a summation of demand in previous n periods. Let's say 3 months period, for example, divided by 3. If it's 3 months, if it's 4-month period, then it will be divided by 4. Let's see an example together. We have this here, the following information for a certain company, which is Salam Supply. Okay, we would like to, as you can see here, to compute the forecast sales for the month of April, May, and June using the moving averages method. Okay. For example, here, look here, if you want to, for example, now forecast the demand for the month of April, then using a 3 months moving averages, of course, the question will decide, okay, how many movement you will make. Here in our question, he's asking us to make a 3 months moving, 3-month moving averages. That's why if you want to forecast the demand for the month of April, then you have to sum the demand for the month for 3 previous months, which is March, okay, February, and January. You just add them, the 3 of them, 13 plus 12 plus 10, divided by 3, okay? Then we will have 11.67, our forecasted demand for next month, which is April. And we will do the same with May, for example. If you want to now forecast the sales for the month of May, then you have also to make 3 movements back. So you will take 30. So you will take into consideration. You will add 30. You will add 16, which is actual demand for April, plus 13 plus 12 divided also by 3, and you will have an answer of 3.67 as a forecasting demand for the month of May. We will do the same also with June. So this is also an easy way to forecast demand by the moving averages. And here I just you can see a lot of examples for many months starting from April to December. In order for you to practice, you have the answers there, as you can see. Okay, because our question was 3 movements, so in each time we want to forecast for a certain month, we will use previous periods, let's say demands, and we will add them and divide by by 3, which is the 3 months movement back. Now, we have another method, which is the third one in the time series. We call it weighted moving averages. It's the same as the moving averages, but here we have different importance weights for the previous periods. For example, we will not here, as you can see in the formula, the weighted moving averages, it will be the weight of period n, a certain period, multiplied by its demand, divided by the sum of weights, مجموع, okay, the sum of weights. Now, why? Because the previous periods, not all of the previous periods is important for us, or it has the same importance for us. Let's see an example. The same example that we talked in the previous slide, uh, also will make a 3-month weighted moving averages. As you can see, it's in red here, 3-month weighted moving averages. Like he is telling to us that you have to take into consideration the importance weight. For example, the most recent month, the weight is 3. 2 months ago, for 2 months ago period, the weight is 2, and 3 months back, the weight is 1. For example, to explain it further, uh, if we want to forecast the demand for the month of April, here as we can see here, okay, then we have to, with the 3 weighted moving averages, and it's given for us that the weight of the previous month is 3. So we'll have 13 by multiplied by 3 plus 12 multiplied by 2 plus 10 multiplied by 1 divided by the sum of weights, which is 3 plus 2 plus 1 is equal to 6. So the total here will be divided by 6, and our demand for next month, or the month of April, will be 12.167. Okay, I can show you the explanation here since we cannot see each other, so that you will understand more. As you can see, last month, which is March in our example, the weight is 3. For 2 months ago, which is February, the weight was 2. And for January, the weight was 1. So the sum of weight was 6. This is just to explain to you again how we did it in the previous slide. As you can see also, you can practice here. You can practice and you can do, or you can do it again for the month of April, May, June, July, and so on in the same way. And there are, of course, yani each method always, as we always study, there is no such quantitative methods without any problems, let's say. Now, the potential problems with the moving averages is that sometimes increasing yani increasing the historical data, let's say, or the previous periods, instead of 3, some people they will make it 4 or 5 movements back. Okay, it will smooth the forecast, but at the same time, it will not really assure that your forecast will be sensitive to changes, because you depend much on the historical data, which may be different from the future. That's why we are always saying that uh, the moving averages, it needs a lot of data, many data, extensive historical data. Unlike the third method, which is the exponential smoothing. The exponential smoothing, it's the same also as the weighted moving averages, but with less data needed. It means that you don't really need intensive data. And here we will use alpha as the smoothing constant, or sometimes we call it we call it smoothing factor, or the weighting factor, okay, which is alpha. And of course, the value of alpha will be decided by the experts, the forecasting expert. Alpha ranges, mathematically speaking, from 0 to 1, okay, and it is subjectively chosen. It means it will be chosen based on the experience of the forecaster. Let's see the formula. It's an easy formula. Look here, look directly to this formula, okay? يعني using symbols instead of words there. If you want to forecast, for example, if you need a new forecast, which is for next period, then you need the forecasted value for the most recent period plus alpha, which is, of course, it will be given in the question always, which is the weight, or we call it the smoothing constant, multiply by the difference between the actual value for the most recent period and the forecasted value. Okay, let's apply it with a simple example. We have here example on the exponential smoothing. Let's say in January, a car dealer predicted February demand for 142 Ford Mustang. Actual February demand was 153 cars or autos. Now, using the smoothing constant, okay, given alpha 0.20, the dealer, okay, or the management wants to forecast March demand using the exponential smoothing model. Let's see how we will apply it. Okay, it's very easy. We will just use the formula easily. We need, of course, we want to forecast for our new forecast will be for the month of March. So that's why it's equal, according to the formula, if you still remember, the forecasted value for February plus alpha, which is 0.20, it's given, of course, here, the smoothing constant, multiplied by the difference between the actual value and the forecasted value for the month of February. Okay, يعني actual and forecasted. So it will be 142 plus zero point 0.2 multiplied by uh, uh, plus zero point 0.2 multiplied by the difference between them, which is 11. Then we will have, as you can see here, okay, 142 plus 2.2, which is equal to 144.2 cars, or approximately 144 cars. Since the cars is, of course, we cannot divide the car into parts. Okay, we can also now we will see further example in order to see the effect of smoothing constants. Smoothing constant alpha. A while ago, I told you that it is, mathematically speaking, it's usually between 0 and 1. يعني, but in practice, alpha is greater than 0.05 and less than 0.50, less than or equal to 0.50. As alpha increases, if you increase alpha as an expert, that means that for you, the most recent or the older value is less important. Okay. Now, let's see how to choose alpha. Yani some people, some experts, they will use a high value of alpha. Some of them will use a lower value. Before we show you or prove it to you that sometimes it's not advisable to increase the value of alpha, let's first try to see the forecasting error. Forecasting error. Now, when you forecast something for next period, of course, the accuracy is not 100%. And of course, we will have a forecasting error. Now, if you want to calculate for the forecasting error, it will be always the difference between the actual value and the forecasted value. Okay? A is a symbol for actual. F is always a symbol for forecasted value. The difference between them, we call it our forecasting error. For example, if I assume, let's say, if I forecast my demand for next year, let's say, by 80,000, and when next year comes, it was 100,000. So what is the forecasting error? It's 100,000, which is the actual one, minus the forecasted one, which is 80,000. Then I will have a 20,000 as a forecasting error. Let's see how we will measure the forecasting error in practice. The first measure, we call it the MAD, the mean absolute deviation. It is simply equal to the sum of deviation, which is the actual, of course, the absolute value of actual value minus forecasted value divided by the number of periods. Now, let's apply it for our example here. Now here in the, of course, in the first column, you have quarters. Yani instead of using month, you can also apply forecasting for, instead of using month, sorry, let's go back. We can apply also forecasting for quarters, as we can see here. The first column here, quarter 1 to 8, actually, because 9, it's not yet forecasted. We have the actual values for our sales here in the second column. In the third column, we have the forecasted value with alpha, which is the smoothing constant, equal to point, given of course, 0.10, okay, or 10%. And we will try also to take the forecast with alpha is equal to 0.50. Now, this example, you see, one time we will use alpha as 0.10, and one time we will use it as 50%, and at the end we will see the difference, where the forecasting error will be less, when alpha is large or when alpha is small in value. Now, as you can see, if we will apply the exponential smoothing method to calculate for the forecasted value, for example, demand for quarter 2, we will take the forecasted value for the month for quarter 1 plus alpha, which is given 0.10, as you can see here, multiply by actual value minus forecasted value, as we applied a while ago. Then we will have a forecasted value when alpha is 0.10, which is equal to 175.50. Okay, we will do the same, but here we used alpha as 0.50. That's why we have a different forecasted value of 177.5, as you notice. Okay, now what we will do here, okay, is we will apply or we'll try to solve for the mean absolute deviation. Absolute, that means that we will not accept negative values. Like here, for example, 168 as an actual value, for example, minus 175.5, okay, it will be, as we can see in the next slide, okay, it should be, of course, it should be negative, but since the formula of MAD is absolute value, then we will have a value of 7.5. Why? Because it's an absolute deviation. Okay, if it's negative, it will be a positive value. Then we will add all of these values together according to the formula of the MAD. So the value, the deviation, the sum of deviation will be 82.45, okay, divided by n, and n here is 8 quarters. So 82.45 divided by 8, we will have a 10.31. This is for alpha when alpha is 0.10. But look, for the same example, the same values, but alpha is different. Alpha here is 0.50. We have, of course, we have a mean absolute deviation, I mean MAD, of 12.33 comparing to the 10.31. So we can, let's say, we can conclude here that when alpha is larger, is 0.50, compared to 0.10, the forecasting error will be also, or deviation, or the MAD will be larger. That means it's better to use alpha as 0.10. In general, when alpha is less, then our forecasting error is less, because 10.31 is less than 12.33. Okay? Now, common measures of error. Another measure, okay, the first measure was MAD. Another measure you can use for measuring error is MSE, which we call the mean squared error. The same, we'll take the sum of deviation, which is the actual minus forecasted, but we will square it. Of course, if it's negative, then it will be a positive value also. They will take the sum and divide also by the number of periods. In our same example, it's 8 because we have 8 quarters, as we can see in the next slide. We will do the same. For example, 180 actual value minus forecasted value 175 equal to 5. Now square it, it will be 25. Look here, for example, for the second quarter. For the second quarter, the error was negative 7.5, but when you square it, it will be a positive 56.25. So if we square all the values, then we will sum them, then we will have a total of 1526.52. And this is the total according to the formula of MSE divided by 8, which is the number of quarters. Then we will have an MSE mean square error of 190.8, of course, when alpha is 0.10. Now, if you do the same for alpha is equal to 0.50, you will notice that the MSE will be greater, will be larger, which is, of course, not advisable. And we will see the result. I will show you the result later on because I did it for you. Okay? But before that, let's go to the third measure of error, which is the mean absolute percent error. We call it as an abbreviation MAPE, okay, mean absolute percent error, which is equal simply to the absolute value of the actual minus the forecasted value, okay, as an absolute value, don't forget, divided by the actual value multiplied by 100 in order to have it as a percentages. Then after that, you have to divide it by n, and our n in our example is 8 quarters, as you can see here in numbers. Okay, so 180 minus 175 is 5 divided by the actual value, which is 180, as you can see. Then divide this by the actual value. Okay, the difference, sorry, 5 divided by 180, which is the actual value, multiplied by 100, we will have 2.78%. Now we will do the same for all. Then we will have a total of 44.75%. According to the formula, this is the total of absolute percent error divided, of course, by 8, which is 8 quarters, as you can see here. We will have a 5.59% when alpha is 0.10. Let's see now or make a comparison between the results that we have discussed, me and you. And to show you here, we will prove for you that when alpha is less, the less, okay, the lesser the alpha, the less the forecasting error is. As you can see, for the three measures that we have discussed, let's just see the result one more time. When alpha is 10, for the MAD, of course, let's see, we have a forecasting error of 10.31, okay, or a MAD of 10.31, which is error, of course. But when alpha is 50, we have a higher mean absolute deviation, which is error, 12.33. So this proves that alpha 0.10 is better than alpha 0.50. The same with the second measure, the MSC, our example, the one we have solved. You see, 195 compared with 190. 190 when alpha is 10 is less than 195 when alpha is 0.50. Again, this proves that it's better to use lower alpha. The same also with the third measure of error that we have used a while ago, as you can see, 59.55, sorry, 0.59% when alpha is 10, but we have 6.76% when alpha is 0.50. So here we have a less, let's say, error than forecasting error than when you use alpha as 0.50. This is just to prove for you, don't always, it's not really advisable always to use high value of alpha as a smoothing constant. Okay. Now, as you can see here, also the comparison again for the final thing. This is for this meeting. Of course, today is Monday. Okay, March 16. This is for the class of Monday, March 16. Now, next meeting, which is Wednesday, inshallah, we will discuss the fourth method of time series, which is trend projections. Okay, so see you next meeting. Please try to see the material, okay, and see this video. And if you have any question, you always ask during the class time. If you have questions, the class time is not online, is not for attendance. It is for your. It is to answer your questions. Thank you very much. Okay. See you next meeting. Thank you.